Okay, today we're going to do the corrections for your procedural fluency test. I decided I'm not giving you the exact numbers. I'm changing the numbers somewhat because these tests are used over and over and they're used by other professors other than me. So I don't want to give those out because I don't know when they might be used them. But I'm going to do the same type problem and just change them a little bit so I can show you how to do it. Now here's what I want you to do. I am going to do this one all the way through and show you how to do the problems. Then if you need to retake the test, I want you to do all the practice. I'm going to send you a practice test to practice on. On Monday, I will send another test, a second attempt that you can take in Lockdown Browser. Okay, so that's three things. First, I'm going to show you the corrections. You watch it. Second, you'll have a practice test. And on Monday, you can do the second attempt if you choose to do so. That's going to be the day it's offered. And it will be Lockdown Browser. So let's get started. The first one was just multiplication, and the question was similar to this. 769 times 48. Alright, so we want to write these vertically. 769 times 48. And I'm going to start off and I'm going to multiply each of these digits by 8. It's important that you know your multiplication facts, your times tables. If you don't, you need to take time to write them out and do them while you're doing the test. 8 times 9 is 72, so I'm going to put the 2, bring the 7 over to this column, regroup it. 8 times 6 is 48, plus this 7 is 55. So I'm writing the 5 here and bringing this 5, trading it over to the next column. 8 times 7 is 56, and 56 times 5 is 60. 56 plus 5, is 61. Now, we're through with these numbers, so I'm going to sort of scratch through them. Alright, now, what I'm actually doing, the reason we move over to this space and not that one, is this is actually a 40 times 9. So, not 4 times 9, but 40. So, that's why a 0 goes there. And I just do 4 times 9 is like 40, but that 0 takes care of it. 36. So, put the 6, and our 3 goes to the tens column. 4 times 6 is 24. Plus those 3 is 27. Okay, and bring the 2 here to the hundreds column. 7 times 4 is 28. Plus 2 is 30. We're keeping these columns aligned right here, so we can add them. 5 plus 6 is 11. 1 plus 1 plus 7 is 9. And then 6 and 0 and a 3 there. Alright, I'm going to check my work really quickly. 2 carries 7. 48 and 7 is 55. 56 and 5 is 61. 4 times 9 is 36. Put 3. 4 times 6 is 24. Plus 3 is 27. 4 times 7 is 28. That's 32. 1, 9. I believe that is correct. Now, number 2 is going to be something kin to 38 minus 62. Now, common sense. Let's just think about it. If you had $38 and you wrote a check for 62, you have gone in the hole, and by that I mean below 0. Because you didn't have enough money. 38 minus 62, you spent the $38 plus some more. So I know the answer is negative. Now, to figure out how much, we're going to change this to 38 plus negative 62. Anytime you have minus, you can change it to plus opposite. And with addition, we can change the order. And I always put the larger absolute value on top. 62 is larger than 38. Negative 62 is not, but I'm putting it there. It's the larger absolute value. And I am going to subtract these. And the reason I'm going to subtract is some are positive and some are negative. I can see I have a whole lot more negatives. And to find out the difference in the two, I will subtract. I can't take 8 from 2. So I'm going to take 1, not borrow it because I don't intend to give it back, and make this 5. Trade that 1 10 I borrowed for 10 1. So bringing 10 over here with the 2 I've already got, that's 12. And 5 minus 3 is 2. And I know that's negative. So I not only spent the $38 I had, but $64 more dollars. And it's negative 24. It's important. There's a big difference if you leave off the negative sign. Negative 24 and positive 24 are not the same thing. All right, number 3. I ask you to estimate something. Let's see. Let's say it's 6886 plus 1174. Now, when you estimate means don't do the math, just round and try to, in your head, come out with a reasonable answer. So I didn't want you to add it and then round. I wanted you to check your skills of estimation. And this is around 7,000. 6,000 is closer to 7,000 because we're more than halfway. 6,500 is halfway. So we're going to round this to 7,000. And this is still more like 1,000 because we're not even halfway. So I'm going to say this is a good estimate is 8,000. All right, number 4 is to write a certain number. And I think the number is something like 14. By the way, some of y'all need to learn how to spell these numbers. 14 million. Let's change this to 7,000. $38. All right. So I know that 14 million, and the next group of 3 is my thousands place. I only need 7 of those. And my next group is my hundreds, tens, ones, 38. So this is, let's check it, make sure. 38. There's your 7,000. And the next group's your millions. There's 14 millions. All right, number 5 was a decimal multiplication. Now, you do not need to line these up. No reason for lining them up. But let's say we're going to do this one. And I'm going to put the longest number here. Now, before I start, I'm going to estimate this answer. And that'll help me decide where to put my decimal point just in case I forget the rule. And I can see that's about 7 times 3. So my estimate is the answer should end up to be about 21. If it should be close to 21. So I'm going to do the multiplication just like I did on that very first one. I'm going to pretend there aren't any decimal points. 9 times 5 is 45. 9 times 3 is 27, plus 4 is 31. 9 times 7 is 63, plus 3 is 66. Now this is like 20 times 5, so we have to put that 0 and move over. All right, 2 times 5, let me scratch these through. We're through with those. 2 times 5 is 10, so 0, and put this 1. 2 times 3 is 6, plus 1 is 7. 2 times 7 is 14. 5, 1, 13, 11. Now, I know my answer for my estimation is supposed to be about 21, so common sense tells me my decimal goes right there because of the estimate. But here's the rule. You look at the problem and you count how many digits are to the right of the decimal point. And I see 1, 2, 3. You look at the whole problem. There's 2 there and 1 there. That's 3. So your answer should have 3 numbers to the right of the decimal. 1, 2, 3. But this estimation surely does help with that. All right, number 6 was a rounding problem, I believe. And it was to round a number similar to this to the nearest thousandth. Well, we've got to find our thousandths place. Anything with the TH is to the right of the decimal. This is tenths, hundredths, thousandths. So that's where I want it to stop. But I have to decide, is the next number at least halfway past this 2? If it is, if it's 5 or more, this goes up to a 3. Okay? And it is. That's 5 or more, so we'll have to make that 216 and 583 thousandths. If this had been a 1, 2, 3, or 4, we would have left that a 2. All right, number 7 was sort of an order of operations, but it had a lot of negative signs in it. So let's see, negative 14 plus 4 times 5 minus 11. Now, in math, you know that we usually do parentheses first. And again, if you don't know what 5 minus 11 is, common sense should tell you. If you have $5 and you spend, and you write a check for 11, you're overdrawn. You spent that 5 plus some more. And to find out how much more, we're going to subtract these. I'm going to make that plus negative. We can tell there's more negatives, so our answer is going to be negative. And if I subtract 11 minus 5, the difference is 6, negative 6. Now, what we have left to do is either add negative 14 plus 4 or multiply 4 times negative 6. Well, multiplication always comes before addition. So I'm going to multiply a positive times a negative, which is a negative. And then I'm going to add the 2 negatives together. And that's like this. That's like you have negative $14 in your bank account. You're already owing the bank money. And you write 24 more. Well, you really owe them money now. That's just even more negative. You're just digging yourself a bigger hole. And if you have 14 negatives and you add 24 more negatives to it, you don't subtract those. We don't need to find the difference. You just got a pile of negatives. How many? Add them together, and that's negative 38. All right, number 8. A lot of people have trouble with division because of not thinking about the fact that you only can bring down one number at a time. When you do long division, you do the same steps over and over. First of all, you divide, and you say division is how many groups of 58 are there in 6? Well, none in 6. But in 61, you can get one group. So 58 into 61 is 1 time. Your next step is multiply. 1 times 58 is 58. Your third step is subtract. 61 minus 58 is 3. And your last step of the process is to bring down the next number, which is, in this case, a 4. Now, you can't bring down but one number at a time. Some people will say, well, 58, there are no groups of 58 and 34. That won't go. No, we'll put a 0. You still have to do these steps. You can't bring down another number. 0 times 58 is 0. Subtract. Bring down the 8. Now this one, Let's see. I know the last number is an 8. And I'm going to think, what 6 times 8 gives me something that ends in 8. So I'm going to try that, and I believe that is correct, because 58 times 6, you may have to go over to the side and figure this out, but it's 348. You may have to go over to the side and do a little checking to see if you can get those. All right, number 9 is order of operations, and nothing is more aggravating to me than to see this done incorrectly, because it's been taught incorrectly. All right, let's look at this. Now we know we're going to parentheses first. Now y'all have all heard, please excuse my dear Aunt Sally, or PEMDAS. But what I don't like about this is there are people that think it's parentheses, exponents, and multiplication before division. That's not true. Multiplication and division are equal because division is just multiplication of the opposite. And addition and subtraction are equal. So actually what you do is parentheses, exponents, and then either multiplication or division in order that you see them, from left to right. And then either addition or subtraction in either order from left to right. But it's whichever comes first. So looking at this, we know we're going to do parentheses first. So I'm just going to recopy that 3. And here I've got addition. No, that comes way down the line. Division or multiplication. Well, these two are equal. And you do those in the order that they come left to right. So I do 10 divided by 2 first. And there are so many people that will think multiplication goes first. It will give you an entirely different answer. A wrong one. Alright, now I'm still in the parentheses. And I need additional multiplication. Again, we have addition in the parentheses, and that's 26. Now, we finished doing everything inside the parentheses, and that's what that means, do everything inside the parentheses. So now we're going to do exponents, and we have 26 to the second power. Okay, well, 26 to the second power means 26 times 26. Well, let's see what that is. 6 times 6 is 36. 6 times 2 is 12 plus 3 is 15. I'm going to scratch that out. I don't need it. 20 times 6, we're going to put that. 2 times 6 is 12. And 2 times 2 is 4 plus 1 is 5. And the answer is 676. And then the last thing I do is add those together. So 379. All right, number 10. This is one that a lot of people have trouble with, and it is subtraction. Not only does it have decimals in it, but it's got all these long numbers, so lots of zeros. Let me put this similar problem down. I'm changing the numbers somewhat. Okay, now, again, I'm going to see if I can estimate what my answer will look like. That way when I get through, I'll have an idea if it's right. My estimate is that's about 36, and that's minus 54. Well, I can tell right off that I am in the negative region, because if I have $36 and I write a check for 54, I've spent more than I had. So I'm in the negative. To figure out the difference, let's see, I'm going to change this to plus negative, and I'm going to write the 54 first. It's negative 54, and I'm going to subtract, and I get negative 18. So my answer is close to negative 18. Now, I'm actually going to do this by putting plus negative. And so this is the larger absolute value. It's farther from 0. That's what an absolute value is. 0, 8, 8, 2, 5, and 36.2003. Now I'm going to fill in this empty space with a 0. Normally the empty space sometimes, well not normally, a lot of times it's on the top number, and if it is, you better fill it in. You can't just drop a number. It's not being subtracted if you don't. Well, I already know the answer is going to be negative, so I'm going to put it down so I don't forget it. Now, I do have to line up decimals when I'm adding and subtracting. I don't when I'm multiplying, but I do when I'm adding and subtracting. And I know we're subtracting here because we want to find the difference. How much more negative is this than the money I had? All right, 5 minus 0 is 5. I cannot take 3 from 2, so I'm going to go over here, and this is like flats and rods and units. I'm going to take one of these and trade it in for 10 of these, which will now make that 12. I already had 2, so I can subtract that one, and that one. That was lucky. Now, I can't take 2 from 0, so I am going over here, and I'm going to take one of these. That's a 1, and I'm going to trade it in for 10 tenths. 10 minus 2 is 8. Put that decimal point. Can't take 6 from 3, so I'm going to take one of these and trade it in for 10 more to go over here, giving me 13. The answer is negative 17.88795, and unless I've made a careless mistake, that's right close to our estimate. But let me show you how to check it. I can check it by just adding these two numbers back up. Take your bottom two, add them back up, and that should check it in any subtraction problem for you. And it will tell you if you end up with the same number, 54.08825, that you're correct. All right, number 11. Okay, this might have been a problem for some of you. Negative 3 squared plus 2 minus 3 squared, no, cubed, minus negative 4 squared. All right, let me tell you before we start this one, there's a big difference in, look over here, this is an explanation. There's a big difference in this and this. Think about Algebra 1. If you have this, only the b is squared, not the a. So this is sort of like this one. Just the 2 is squared, not the negative. The negative's not part of it. It's 2 squared is 4, and the negative had nothing to do with it, just like this a has nothing to do with that. Now, from algebra, if it's in parentheses, that means square everything in the parentheses. So here, this means square both. It's negative 2 times negative 2. That one is positive 4. So now let's try this over here. This negative has nothing to do with that square. So it's just negative 3 times 3 is 9. We're going to do what's in the parentheses, which gives us negative 1 to the third power. And we're going to do not do plus positive. You've got to do exponents before you, that's like distributing, which is multiplication. You've got to do this first. So leave that minus sign alone, and a negative 4 squared becomes a positive 16, because a negative 4 times a negative 4, any negative times a negative is a positive. Okay, now we still need to clear this middle one up. We have a negative 1 to the third power. That means negative 1 times negative 1 times negative 1. Well, we already know that a negative times a negative is a positive, and a positive times a negative is a negative. Anytime there's an odd number of negatives, it's still negative. And this minus 16. Negative 9 plus negative 1 is negative 10. And if you'd like to change that minus sign to plus negative, A negative 10 plus a negative 16 is a negative 26. Now, the last one was to tell, and I'll write this number backwards, 9, 8, 7, 6, 5, 4, 3, 2, 1. And tell which one is in the 10 millionths place is what I asked. Well, I'm going to split these up into groups of 3. These are your regulars, your hundreds, tens, ones. These are your hundreds and tens, ones, but they're thousands. They have a last name, thousands. And this is the million family, and these are your hundreds, tens, ones. So these are the millions family. Here's the 10 million. Whoops, you didn't see one thing I wrote. Let me do it again. Here, I split them up into groups of 3. 3, 2, 1, 6, 5, 4, and 9, 8, 7. They all have hundreds, tens, ones. Hundreds, tens, ones, hundreds, tens, ones. But this family is the thousands family. They have a last name. And these are the millions family. So, if you're looking for the 10 millions, it would be this 8. And that's our answer. All right, I will send you a practice test for you to do. And hopefully you can do a little better this time if you practice. And you'll understand the point is that you learn this. Anybody who's going to teach should be able to do this. So good luck with that.